Hello everyone. So today we will continue with the unit 3, which is statistics in industry and commerce, and we will cover understand the use of ANOVA, which is analysis of variance tests in a business context. In this session, we will explain the use of ANOVA tests in business context, identify the main assumptions uh, uh, which underpin the ANOVA tests, then explain the use of a Latina square in a business context, then describe using examples how to conduct one and two-way analysis of variances, and explain using examples how different results can be interpreted. And finally, we will also analyze the assumptions underpinning ANOVA tests. So before we move into each of the learning outcomes, let us first look at the key terminologies. So now, when we are using patterns of business data to theorize about future performance, so ANOVA, it helps in identifying the patterns and analyzing the patterns in business data. For example, projection of revenues, costs, customer satisfaction across different groups or time periods, such as regions, products, and quarters. Then identification of trends and relationships that can be used to theorize and forecast future performance. Then, for example, ANOVA can show sales in a region A that are significantly higher than other regions. So it can theorize and project this higher growth in region A will continue. Then the next aspect is to identify the root cause of positive or negative performance. So by comparing means across groups, ANOVA pinpoints where significant differences exist. So it helps in identifying the root causes. For example, ANOVA may reveal product A has a significantly lower profit margin than others. So this signals need to investigate costs and pricing issues for that product specifically. Then assumptions and implications. So key ANOVA assumptions include random samples, normal distribution, equal variances, and need to assess if assumptions they are reasonably met via graph statistical tests. So any violation in these assumptions can invalidate the results. So for example, data may need transformation for normality. So if the data does not have a normal distribution, we need to transform the data into normal distribution. So samples with unequal variances may require alternate tests. Then Latin square design and use in business. So this also we will cover in today's session. So Latin squares control additional sources of variation by building in balancing of rows and columns. So it is useful in business when testing effects of multiple extraneous factors like locations, days, batches are considered. And then it also allows isolating impact of true experimental treatments or conditions. And one and two-way ANOVA analysis. So one-way ANOVA, it compares single factor and treatment, means like, for example, sales across regions. Then in two-way ANOVA, it examines the interactions between two factors like pricing and location. The ANOVA can be carried out using statistical software, which runs the analysis and calculate the F statistics, P, which is significant values for significance testing. So this we have already covered in previous sessions. And then interpreting the ANOVA findings. So the ANOVA output is interpreted by significance of F test and P values, post hoc tests on group differences. Then you have statistically significant P values indicate true differences exist between group means, and the findings they help the managers to take informed business decisions, and it can be used in different business departments such as operations, marketing, HR, and strategy based on results. So first we look into the use of ANOVA tests in business contexts. So the ANOVA, which is the short form for analysis of variance, it allows comparing of the means of different groups to determine if there are any statistical differences between the means of the different groups. So this is useful for many business applications. So ANOVA test can be used to analyze patterns such as sales figures, costs, customer satisfaction scores, etc. across different groups like geographical regions, product lines, time periods, and marketing campaigns. So this is where ANOVA is most commonly used in business decisions. So by analyzing the difference in means, businesses can identify trends and relationships in the data to theorize and forecast future performance. So for example, ANOVA can show if there are differences in average revenue by region, product, marketing campaign that are statistically different. So by analyzing the results, you can make decisions about these data points. So ANOVA, it also helps business in identifying potential root causes behind positive or negative results. So if ANOVA reveals that one product line is significantly less profitable than others, then it signals a need to investigate costs, pricing, and demand issues. So basically, it all relates to how the ANOVA and the statistical tests can be used for making business decisions. So for ANOVA results to be valid, the key assumptions are samples should be randomly selected, the data should follow a normal distribution, and the variances should be equal across groups. So violations could lead to unreliable results. So there are different types of ANOVA tests like one-way ANOVA, two-way ANOVA, and multi-way ANOVA. So it depends on a number of independent variables being analyzed. Businesses can accordingly choose the appropriate test for their needs. So in conclusion, overall ANOVA is a very important statistical tool, and it can help in business analytics and provide data points so that business decisions can be made. It provides an objective way to compare group means and identify significant patterns that can guide actions to improve the performance. So the next one, we look into the different assumptions underpinning the ANOVA test. So what are the key assumptions that guide ANOVA tests? So in this, the first main assumption is normality, which is normal distribution. So the data within each group or category is assumed to follow a normal distribution. So this means that the data should have a symmetric bell-shaped distribution when plotted. So normality is assessed visually through histograms and QQ plots and using statistical tests like Shapiro-Wilk test, Kolmogorov-Smirnov tests. So these are the common tests which are used to assess normality in statistics. Then non-normal data can increase the chances of type 1 error, which is incorrectly rejecting the null hypothesis when it is true. It can also affect the power of the test. So to convert, if the data does not follow a normal distribution pattern, the transformations like log, square root can help normalize highly skewed data. So removing the outliers can also help in this regard. So homogeneity of variance. So another key assumption in ANOVA is that is the homogeneity of variance. So the variance or spread of data within each group is assumed to be equal, which means the group should have similar variation in values. And then we have the data should be tested using Levine's test and visual inspection of box plots, which means unequal variances is called heteroscedasticity, which should be avoided when you are using when you are testing for homogeneity of variance of data. So violations can increase type 1 error rate and reduce power. So type 1 error is incorrectly rejecting the null hypothesis. Then weighted ANOVA methods like Welch ANOVA can help address this. So the next assumption is independence and random sampling. So with respect to independence, all observations and measurements should be independent of each other. The samples should not influence each other. Then we have violations. Any violations in independence can underestimate the standard error and impact the results. So therefore, there should be sufficient spacing between the samples. And then time series data may show autocorrelation and need pre-whitening transformation. So accordingly, the data should be transformed to meet the independence assumption. Then we have random sampling. So a random sampling is one of the most important uh, characteristics and assumptions in a ANOVA test. So this means that the samples drawn from each population should be random to avoid selection bias. So any non-random sample can skew the results and reduces generalizability of the findings. So simple random sampling is ideal, although cluster stratified and these things can also be used for this test. The next assumption is no outliers, which means that there should be no outliers are basically which have a very large values as compared to the means. So that should be avoided in any data that you're selecting. And so ANOVA is sensitive to outliers, which can distort the results. So unusual data points need to be assessed. The outliers assessed using visual plots. They are like statistical tests like Grubbs test. So trimming or removal can also be considered if the outlier has been included due to error. And then the data transformation can also be done to normalize the outliers. For example, robust ANOVA methods can accommodate outliers. Then we have balanced design, multi-way. So for when you're conducting multi-way ANOVA, there should be a balanced number of observations per group and combination of factors. So unbalanced designs can have less power to detect differences and interactions between factors. So this is basically applicable for multi-way ANOVA. And again, a sufficient sample size is needed in a multi-way ANOVA test. So these are the key assumptions which are used in the ANOVA. So in conclusion, validating these assumptions is very crucial for reliable ANOVA results that allow valid statistical inferences. So remember, if there are if the assumptions are not met, then you may not be able to analyze or the data may give false results, which can ultimately have implications in business decisions. So it is very important that these assumptions are met. So next we look into the use of a Latin square in a business context. So in a business context, Latin square can be a valuable experimental design technique to control and analyze various factors that may influence a particular outcome or decision. So what is basically a Latin square? So it is a structured experimental design that ensures the systematic manipulation of multiple variables while minimizing bias and controlling for confounding factors. So it falls under broader category of factorial design. So it is particularly useful when a business wants to study the effects of two or more factors simultaneously while minimizing the influence of external variables. So one of the key characteristics of a Latin square is that it ensures orthogonality, which means that each level of one factor occurs equally with each level of another factor, reducing the potential for confounding variables. Then applications in a business context. So Latin squares can find applications in various business scenarios, including marketing, product testing, and process optimization. So some of the specific use cases include product testing. So businesses often they need to test multiple variations of a product before the product is launched into the market. So it could be the various factors may include pricing, packaging, advertising, and which lead to a highest acceptance of the product and high customer satisfaction. So Latin squares can be used to systematically vary these factors while ensuring each combination is tested, reducing bias in the results. Then the next area of application is inventory management. So in supply chain and inventory management, businesses may want to assess the effects of factors such as reorder points, lead times, and order quantities on inventory costs and service levels. So Latin squares can help structure experiments that vary these factors efficiently. Then you have market segmentation. So when conducting market research, companies might want to analyze how different marketing strategies, for example, social media advertising, email campaigns, and influencer partnerships impact customer engagement and conversion rates. So Latin squares can help control for various marketing variables. So now we have studied Latin square. Now next we look into how to conduct one and two-way analysis of variances, which is ANOVA. So conducting one and two-way analysis of variances or ANOVA is a critical statistical method used in research and business context to compare means among groups or factors. So how can we conduct these analysis with examples? So one-way analysis of variance or ANOVA. So step one is to formulate the hypothesis, which is the null hypothesis and alternate hypothesis. So the null hypothesis is generally taken as there is no significant difference among the group means, and alternative hypothesis is there is a significant difference among the group means. So this is the first step in ANOVA testing. So the step two is collect and organize data. So gather data from different groups or factors. Then step three is using statistical tools such as SPSS to compute the F statistic and associated p-values. So, and then the fourth step is to interpret the results. So when you do step three, you will see the extent of validity of the regression model and whether you obtain statistically significant results or not. And when you interpret the results, if the p-value is less than a chosen significance value, then the null hypothesis is rejected and the alternate hypothesis is accepted. So this implies that there is a significant difference among the group means. The next one is two-way analysis of variance. So in this, the statistical test of ANOVA is carried out by considering the influence of two categorical independent variables or factors. So in this, step one is to formulate the hypothesis. So the null hypothesis is there are no significant main effects or interaction effect between the two variables. So remember here we are taking two or more variables. Here we are considering two variables. So in then the alternative hypothesis is there are significant main effects or interaction effects in the variables. So again, similar to ANOVA, one-way ANOVA, in two-way ANOVA also we collect and organize the data, and then we calculate the two-way ANOVA using the statistical tests, using a statistical software of SPSS. So here we compute the F statistic, which is obtained in the output results of SPSS software. So basically, we use the F statistics to analyze the effects and interaction effects and the associated p-values. And finally, the interpretation of the results. So the p-values are analyzed for main effects and interaction effects. So if p-values are below the chosen significance level, we conclude that there are significant effects. So next we look into how different results can be interpreted. So explain using examples how different results can be interpreted. So in this, interpreting the results is very important. For example, if you conduct a statistical test, you should be able to interpret all of the values and what are its implications for a business. So it always involves drawing meaningful conclusions from statistical analysis. So to explain this process, let us look at an example with respect to the factors which influence the employee productivity in a company. So the regression equation is productivity is 10 plus 2 times experience minus 1.5 times workload plus 5 times training productivity, which is 10 plus 2 times experience minus 5 times workload plus 5 times training productivity. So the intercepts 10, which represents the expected productivity when all predictive variables are 0. So when you have workload is 0, when training productivity is 0. So that the productivity is only 10. Now, what the coefficient for experience indicates, here we have, the coefficient for experience indicates that for each additional year of experience, productivity is expected to increase by 2 units. Then the coefficient for workload, which is minus 1.5, suggests that for each additional unit of workload, productivity is expected to decrease by 1.5 units. And then the coefficient of training means that for each additional training session, productivity is expected to increase by 5 units. So this is the interpretation of a one-way ANOVA test. Now, here we have considered one-way ANOVA test to compare the average customer satisfaction scores for 3 different service levels, which is basic, standard, and premium. So the interpretation is that if the ANOVA test yields a significant result, which is P is less than 0.05, then we conclude that there is a significant difference in customer satisfaction among the different levels. Then we have the post hoc test. For example, Turkey's HSD, which can be used to identify which specific service levels differ from each other. So that is an example of one-way ANOVA. Now, two-way ANOVA. So here we have performed a two-way ANOVA to assess the impact of advertising channel and time of day on product sales. So we look into, so the results of the ANOVA. So if the two-way ANOVA results indicate a significant main effect for the advertising channel, which means the significance value is less than 0.05, it suggests that the choice of advertising channel has a significant influence on sales. If there is a significant main effect for the time of day, which means that P is less than 0.05, it implies that time of day also has a significant impact on sales. For example, if you are advertising anything about daytime where many people will be in office, they may not be able to view the television. But at night when people are watching television, you will have more viewership. So that will have an impact on sales. So if there's a significant interaction effect between advertising channel and time of day, it means that the combined influence of these factors on sales is not simply additive, and there's a unique effect when they interact. So that is only observed by a two-way ANOVA. So next we look into the unit where you can achieve merit grades. So which is to analyze the assumptions underpinning the ANOVA tests. So we already discussed what are ANOVA. So these are powerful statistical tools, but they are based on certain assumptions. So this is what you need to analyze when you are conducting ANOVA tests. So independence assumptions. So the observations or data points within each group are assumed to be independent of each other and they do not interact with each other. In other words, the values of one observation should not depend or be influenced by the values of other observations in the same group. That is the main independence assumptions in an ANOVA. The normality, like we already discussed earlier, the residuals or the differences between observed values and predicted values for each group should follow a normal distribution. So the assumption is primarily related to the normality of the residuals, not necessarily to the normality of the original data. Then homogeneity of variance assumptions, which is homoscedasticity. So the variances of the residuals should be approximately equal across all groups. In simpler terms, the spread or dispersion of data points around the group means should be similar for all the groups. So that is homoscedasticity assumption. Then mutually exclusive and exhaustive groups. So the groups or categories being compared in the ANOVA should be mutually exclusive. That is each observation belongs to only one group, and collectively exhaustive, which means all observations are included in one of the groups. Then we have random sampling assumption. So again, here a simple random sampling is the most preferred choice for sampling technique. So such that the sample is representative of the population from which it is drawn. So this assumption is particularly important when making inferences about the population based on the sample. Then equal sample sizes for one-way ANOVA. So in a one-way ANOVA, when you are comparing across the multiple groups, it is ideal for the sample size in each group to be approximately equal. For example, you are collecting mean of sample one, mean of sample two. So sample size should be equal. However, ANOVA is robust to unequal sample sizes if other assumptions are met. Then we have independence of errors. So the errors from the model should be independent of each other, meaning that value of one residual should not predict or influence the value of another residual. So that is another key assumption with respect to ANOVA that you need to take into account when you are carrying out ANOVA tests. Then we have linearity or regression analysis. So in regression ANOVA, if you're examining the impact of a predictor variable on the dependent variable, there should be a linear relationship between the predictor and the dependent variable. So normally in regression, you use two or more independent variables. So those are called predictor variables. And then checking the assumptions. So various statistical tests and graphical methods, for example, normality plots, residual plots can be used to assess whether these assumptions are met. So violations of these assumptions can impact the validity of ANOVA results, and appropriate data transformations or parametric tests may be considered in such cases. So that is how you check the assumptions. So that is all for today. In case if you have any doubts, you can let me know.